In one of previous videos, we have reviewed the process of shell plate expansion. Now let us analyze the result of this expansion. Here you see the hull drawing with surface of the plate and expansion of this plate. What do we have in this file? First of all, we have surface of the plate. On this surface we have now one more mark line, which is sight line. And we have template calculated by this sight line, as well as templates on each frame which was marked on the surface. This is what we get in 3D. Now let us review what we have in the expansion. I will switch to the top view and first of all we have expanded shell plate. We have also orientation icon, which is placed in the center of the plate. And we have mark lines which were on the 3D surface of the plate. We have these lines expanded on the expansion. Next to the expansion, we have set of transverse templates. Each of the templates have a label which contains information which was marked in the list of options. In our case, this is plate name, mark line name, sight line height, and bracket angle. The letter F after the bracket angle means that this angle is calculated or is measured from the front side of the template. Letter A means that angle is measured from the aft side of the template. Except of transverse templates, we have template on the sight line. And on this sight line template we have mark lines from all transverse templates. As well as on transverse templates we have mark line from the sight line template. As I told you before, it's very convenient to cycle colors of the templates. Then you can easily define which template corresponds to which mark line on the sight line template and on the surface. On each transverse template, mark line of the sight line has the symbol for correct positioning of this template on the plate for bending. Direction of this symbol corresponds to the alignment icon, this red arrow, which is placed on the plate as mark line. What else do we have on the plate? First of all, we have several diagonals. If we will move labels, you will see that these dimensions show us length or distance between the points in 3D and on the expanded plate. So if we will take this point, frame 83, and this point at frame 65, this blue diagonal, we will see that in 3D the distance is 10 meters 956, and in the expansion it is 10 meters 982.5. So this information can be used for the checking of the plate after cutting and after bending. Also, around the plate we have so-called forming control labels, which tell us how much this segment of the edge was deformed during the expansion. Be aware, this is not deformation during the bending, it's deformation of the surface during the expansion. And we have label of the plate, which contains plate name and deformations during the expansion, minimum and maximum length difference. So in our case we can see that maximum length difference is 0 and minimum is minus 2.2 millimeters, or in percents it will be these values. What can we get from this information? You can use it in the way that if you see this minimum or maximum strain bigger than 0.5%, that means that you have to do something with this plate, most probably. Either you have to give a green material, or maybe you need to split the plate into several plates to reduce the deformation from expansion. Anyway, something has to be done with such plates. This information about the deformations can be exported into the text format using SCHAL surface expanded surface deformation table. I will select the expanded plate, and deformation table can be calculated by the expansion mesh. So you can get deformations on U and V direction lines of the mesh, or it can be calculated on the mark lines. You can get deformation on the mark lines which are marked on the plate.